Okay. Good morning, all. Please confirm that my presentation is visible and my voice is clearly audible.
Yes, sir.
Okay. Okay, we will start then. Uh, uh, in last lecture, we have discussed related to the age hardening. Then, what is the meaning of age hardening? What are the minimum requirements or conditions for that particular alloy to show that age hardening? Then, how to carry out that age hardening process? And the different factors affecting the kinetics of the age hardening process. Then in this lecture we are going to discuss related to the some non-ferrous alloys that we are going to deal with lead and tin alloys, then the nickel alloys, and after that nickel alloys we will discuss related to white metal alloy, that is Babbitts. And then we will start one by one. First is the lead and tin alloy. Now here in diagram you can see clearly this is the equilibrium diagram. This is equilibrium diagram for lead and tin. Okay, lead is so its chemical symbol will be Pb and Sn is the tin. Okay, on this x-axis weight percentage of tin is taken. On y-axis temperature is taken. Now here this is just for your reference purpose, no need to remember this diagram, they are not going to ask this diagram. Okay, then what you have to remember here, it is the eutectic composition and the eutectic temperature point. Now here for this lead and tin, you can say that eutectic point is at 61.9% tin, and the eutectic temperature is 183 degrees Celsius. Okay, the temperature will be 183 degrees Celsius. Here you can see it, and eutectic composition is 61.9% tin. Is the eutectic composition, and this is the eutectic temperature. Now, in general, this is the composition I have mentioned here: lead and tin alloys. And their lead will act as the base metal or parent metal. Then alloying element will be tin, and some small amount of the other alloying elements may be there, like SB is nothing but the antimony, then silver, arsenic, zinc, and cadmium. These four or five alloying elements may be present or may not be there. Okay, you can say that in general, these are the alloys of lead and tin, with or without addition of these alloying elements like antimony, silver, arsenic, zinc, and cadmium. Then after this general composition, there are specific properties of this lead and tin alloys. They are having relatively very low melting point, very low melting point. Here you can see that at this particular composition, its melting point, you can see that it is 183 degrees Celsius. It will get transformed directly to the liquid. Then all these lead and tin alloys has a very low melting point, and they will show you excellent flow characteristics. Okay, excellent flow characteristics and low melting point, these are the characteristics of these lead and tin alloys. Now due to these characteristics, these are used for the purpose of, these are used as a solder material during the performance of the soldering operations. Okay, it will come in the application. Okay, these lead and tin alloys, these will be used as the solders for performing the soldering applications. Now depending on the composition, there are different types of the solders. Approximately four types of solders are available. Depending on their applications, the name is given here. The first solder which is available is, you can say that, Tinman solder or quick solder. Now it will be a lead and tin alloy, and here composition will be like this: 62% tin, and remaining, that is the 38% lead will be there. Okay, this is the Tinman solder, or it is also known as the quick solder. 62% tin and remaining amount of the lead, that is 38% lead will be there. Now it is having very low melting point. Now if you see, refer your equilibrium diagram, that is 62% tin means this 61.9 Okay, approximately equal to this means its melting point is very low, that is 183 degrees Celsius will be melting point. That's why these are used for performance of the soldering operations, and can be used for joining of the different wires of the TVs, radios, or different kinds of the electrical equipments wires. Okay, so these, I think you have seen this for joining of the wires, which electrical wires of different equipments. We are using one soldering material. That soldering material will be termed as the Tinman solder or quick solder. Okay, soldering is nothing but here we are going to join the two different metals, and one metal, here directly we are using as the filler metal. It will get joined to the another metal. And what is the difference between soldering and brazing operation? Generally soldering operation will be performed at the lesser temperatures, approximately lesser temperatures than the 500 degrees Celsius, and brazing operations is performed above 500 degrees Celsius temperature. Okay, now after this Tinman solder, the next solder is the plumber's solder. Now here this plumber solder its composition will be 20 to 40% tin will be there, and the remaining amount will be of lead. Okay, no other alloying element will be there. Now the, uh, the plumber solder, which is used widely, it has composition 67% lead and 33% tin. This will be generally used plumber solder. Now why it is termed as the plumber solder? Because it is used for joining uh, different kinds of the pipes or different kinds of the cable sheets. Okay, that's why it is termed as the plumber solder. Its general composition, it will vary in this range, 20 to 40% tin and remaining amount of the lead. And most widely used plumber solder is 33% tin and 67% lead. And these are used for the joining of the different lead pipes, and cable sheets are there that can be joined with the help of these solders, and it is commonly known as the plumber solder. Then after this plumber solder, the next solder material which is used is the, you can say that, turny metal. Turny metal, it is an lead and tin alloy with tin. It will vary in this range, 10 to 25% tin, and remaining amount will be of lead. And now what are the applications here? These metals are used for just providing the coating on the steel sheets, whichever steel sheets we are using for the roofing or automotive fuel tanks. Whichever steel materials we are using, on that steel material one coating will be given of these materials, that will be termed as the turny metal, and its composition will vary in this range, 10 to 25% tin, and balance or remaining amount will be of lead. Okay, then the next solder is the electrician solder. Its general composition will be 58% lead and 42% tin. And as the name itself indicates that it is electrician solder, why it is termed as electrician solder? These soldering materials are used for joining of the wires of the different electrical instruments. It may be TV, radio, or different whichever appliances you are using. Your different home appliances may be there. They will be having some wires. To join that wires, this solder is used, that is termed as the electrician solder. Its composition will be 42% tin and 58% lead. Okay, so these are the different lead and tin alloys, lead and tin alloys. Here we have discussed the four lead and tin alloys: Tinman solder is also known as quick solder, then plumber solder, then turny metal, and the electrician solder. Okay, here for each material, I have mentioned here its composition and application. Composition, application, and properties for each soldered material will be common. That is, they will be having very low melting point, and their excellent, they will have, or they will show excellent fluidity. Okay, excellent fluidity, which these properties I have mentioned here: low melting point and excellent flow characteristics. Okay, so these are the different types of, for each you have to write in this way: First, you have to write the composition, then properties. Composition here I have mentioned, and properties will be common for all four types of solder materials. That is, they will have low melting point and they will show excellent flow characteristics. And applications, according from their name itself, you can write their applications. Okay, so these are the four types of the lead and tin alloys. Okay, in this way, we have completed this part. Only this much part is in your syllabus, some lead and tin alloys. Okay, and then after this lead and tin alloys, the next will be the nickel alloys. Next point is the nickel alloys. Now before actually discussing the what different nickel alloys, approximately here 9 to 10 nickel alloys I have taken here. Okay, but in examination they will ask you very few names, and if they have asked you a general write a short note like questions on nickel alloys, you have to mention the properties of the nickel, uh, general characteristics of the nickel, and after that you can mention just two or any two or any three nickel alloys along with their composition properties and applications. Okay, if they have asked the short notes. Okay, we will go one by one. First we will discuss related to the properties of the nickel alloys. Now here nickel has FCC crystal structure, that is face centered cubic crystal structure. And as you already aware of these things, that is with if a material is having FCC crystal structure, it will be soft, malleable, or ductile in nature. Okay, in the same way that nickel, due to this FCC crystal structure, it will be soft, malleable, and ductile in nature. Now, related to its other properties, the nickel will be having white color. Then it will show very good resistance to the corrosion as well. Will show very good resistance to the corrosion as well as to the oxidation. Then the next property is it is having fairly good electrical conductivity. Its electrical conductivity will be not as better as copper or aluminum materials, but it is fairly good. You can use it for some applications. And then this nickel has characteristics that it can get easily alloyed with the different alloying elements. It may get alloyed easily with the chromium, then you can alloy it with the iron, manganese, then you can add it alloy it with the silicon, like this, depending on your desired characteristics or properties required in your component. This nickel can get alloyed with the different alloying elements very easily. Then these in last point I have mentioned here some common applications. These are used in the production of the copper nickel alloys. Then has some high temperature alloys. Then different types of the magnets are there. And high nickel alloys or for the giving the electroplating. Electroplating is nothing but we are providing one metal coating on one metal. Suppose there is a steel metal or alloy, on that we are going to provide some another alloys coating on soft, means the when thin coating will be provided, that process will be termed as the electroplating process. Okay, in short you can remember it as a just we are going to provide one metal coating on the another metal or the alloy. Okay, then these are the general characteristics along with some common applications I have mentioned here for nickel alloys. After that we will discuss some nickel alloys along with their composition. Then some different properties alloying, different properties will be there according to the alloying elements added in it and their applications. Now we will start with this Dura nickel. This is the first nickel alloy. Here I have mentioned its composition. 94% nickel will be there in the Dura nickel. Then 4.5% aluminum will be there. Okay, Dura nickel, it is the alloy of, you can say that, nickel and aluminum. Aluminum will be alloying element, and some small amount, very small amount of other alloying elements like carbon, iron, manganese, silicon, then copper, titanium. Very small amount of these other alloying elements will be added there. Here major or principal alloying element will be aluminum, and this nickel will be the base metal. Okay, this is the composition for the Dura nickel. Then what are the properties here? It will be having very high tensile strength, then it will show high hardness, and very good corrosion resistance. They will show very good corrosion resistance. Now, applications for these Dura Nickels, these are the Dura Nickels. First, we will manufacture these strips with the help of this Dura Nickel. That strips will be used as the laundry clips, and then it can be also used for the manufacturing of different jewelry parts or optical frames. We are using that optical frames which are having white color, that can be manufactured with the help of this Dura Nickel, which are having very, you can say that lighter in weight also, due to addition of that aluminum. Then, and it will look little bit attractive. Then different instruments parts, like such as then diaphragms, bellows, then snap switch blades. Then in the sports fields for fish hooks are there. Then the parts of the fishing tackles different. You can say that you can in the general, you can easily remember the application is, it will be used for manufacturing of the strips. That strips is used in the laundry clips, then used as a laundry clip, then in the different jewelry parts, then optical frames, that can be easily remembered, and the application for this Dura Nickel. Then after this point, the we will move towards the next nickel alloy, that is the Perma Nickel or Perma Nickel alloy. Now here, its composition will be, base element will be nickel and some small amount, okay, very small amount of alloying elements like carbon, manganese, then iron, silicon, sulfur, titanium, magnesium. These are added. Now here, it will be having high tensile strength, high hardness, and good corrosion resistance. One more characteristics here, due to the presence of this copper, you can say that it will be having better thermal and electrical conductivity. Now, and as this is have these elements are having better thermal and electrical conductivity, these are used for manufacturing of the different electrical contact, okay, different electrical contact components. Like you can see that the different springs are there for electrical contact, that are manufactured with the help of this Perma Nickel. Okay, so these are the composition properties and applications. Okay, approximately 9 to 8 to 10 nickel alloys I have taken here. Okay, for each you have to remember the composition, approximate composition. Here percentage little bit here and there, means some point difference it can be considered. Then next is the Hastelloy D Nickel, or it is also termed as the Hastelloy D. Now here, it is also alloy of the nickel as the parent metal, and alloying elements will be silicon and copper. Its composition will be approximately 10% silicon and 3% copper will be there. Okay, it will be having high tensile strength, high toughness, hardness, and excellent corrosion resistance will be there. Excellent corrosion resistance it will show. Now these are used, these Hastelloy D nickel or Hastelloy D, these are used for in the evaporators, then reaction vessels, in different pipelines, and different fittings in the chemical industry. And if you are not able to remember these names, just try to remember the industry that is it is used in the chemical industry. And in the chemical industry, different pipelines will be there, different fittings, different evaporators or different reaction vessels will be there. There you can use this Hastelloy D or Hastelloy D nickel. Then next, these nickel alloy is the inware. Now already it will be considered as a nickel alloy, but already this we have seen in the steel steels. Why we have learned this? Because its parent element will be iron, that is 64% iron will be there, and 36% nickel will be there. Already this we have discussed in brief inwares, in the inware steel, the type of the different types of the alloy steels, in that we have discussed this. Okay, in short I will explain it again. It will be having 64% iron and 36% nickel. Now what is the basic or very important properties this inware has? It will have very low coefficient of thermal expansion. That's why these are used in the measuring instruments, different types of the measuring instruments. Then it may be measuring tapes, then length standards, then different instruments parts where precision measuring is required. At that time you can use these inwares. Okay, inware material, 64% iron and 36% nickel, and it will show very low coefficient of thermal expansion. That's why in short you can remember that these are used for manufacturing of the different measuring equipments like tapes or different length standards which are used. After this inware, the next nickel alloy is the ill inware. This also we have discussed in brief. Characteristics will be same, just the composition will be different here. Extra chromium will be added, 12% chromium is added here. You can application, you can here easily remember that it is used in the manufacturing of the different parts which can be used in your watches or different precision instruments. Here it is used for manufacturing of the hair spring. Okay, hair spring is there for manufacturing of that hair spring which is used in the watches. Okay, hair spring or balance wheels are there in the watches or different precision instruments. There these parts are manufactured with the help of this ilinware. Inware and ilinware, both will have similar characteristics, that is they are having very low coefficient of thermal expansion. And what will be the difference in the composition? Inware will have 64% iron and 36% nickel. And in this we will in the ilinware we are going to decrease the amount of iron and 12% chromium is added. Okay, and these are used in the precision equipments or manufacturing of the different components of the watches, that ilinware. And inware is used for manufacturing of the different measuring instruments. After this, some alloys of nickel, chromium and iron alloys, nickel, chromium and iron alloys. Here I have taken few compositions for the examples: 80% nickel, 20% chromium, then 60% nickel, 16% chromium, and remaining amount, that is 24% iron. Okay, alloys of nickel chromium or nickel chromium and iron alloys. Now due to this presence of the, you can say that chromium, it will show the higher resistance to the oxidation, higher resistance to the oxidation. Then other general properties will be there, they will show you high tensile strength also and high hardness also they will show. Now where these are used, nickel chromium and iron alloys, these are used as a electrical element or heating element, you can say that electrical element. Or okay, here you can say that it is electrical element, or you can say that electrical heating element. Whichever heating elements are present in our different home appliances are there, like hot water heaters are there, then you can say that your hair dryers, then toasters are there. In these different equipments or home appliances, there will is a requirement of one heating element. That electrical heating element is made up of these alloys, nickel, chromium and iron alloys. Whichever heating elements are used in different home appliances, if your different home appliances means that whichever equipments you are using in your day-to-day lives, that's some toasters, hair dryers, hot water heaters, or simply you can say that water heaters are there. Then different industrial furnaces are there. In the industrial furnaces also, in that furnaces we require some heating element. All these heating elements are manufactured with the help of these nickel, chromium and iron alloys. Okay, so these are the nickel, chromium and iron alloys, and these will be included in the nickel alloys, as these are having higher amount of the nickel, or it will nickel will act as the parent element here. Chromium and iron will be alloying element. it will be having higher oxidation resistance than Inconel. Now here Inconel is the alloy of the nickel as the parent metal, and chromium and iron will be alloying element. Here chromium will present in the 15%, approximately 15%, and 8% of the iron will be there. Sorry. Now it will show very good strength, high strength will be there, and very good resistance or higher resistance to the corrosion and oxidation. Okay, and their applications will be like this. These Inconel or these Inconel alloys will be used for manufacturing of the different exhaust manifolds which we are using in the aero engines, then manufacturing of the different furnace parts, and carburizing boxes will be there, then different kinds of the retorts. Retorts is nothing but that chemical equipment which we are using in the labs, chemical lab or chemistry labs. Then different thermocouple protection tubes, then food processing equipment, different food processing equipments are there. There we are using these Inconel alloys. Okay, now after this Inconel alloy, the next alloy will be Inconel X will be there. Inconel X. What is the difference in this Inconel and Inconel X? Just in this percentage of chromium and iron will be same, just we are adding small amount of titanium and aluminum will be added. 15% chromium, 8% iron, it will be same as that Inconel. Just the titanium is added in small amount to 2.25 to 2.75%, and zero point 0.4 to 1% aluminum is added here. Aluminum is added. Now due to addition of this titanium, which properties will be improved here? High strength, then high resistance to oxidation and corrosion will be there. But due to addition of this titanium, what will happen? You can use this Inconel X at the higher temperature conditions, that is at the elevated temperature. uh, Also you can use these alloys, and now these are used for manufacturing of the different springs, and these springs are used at the elevated temperatures, that is the higher temperature ranges services. Then it can be used in different okay, these same springs you can use in the different gas turbines, then jet propulsion parts. All these can be manufactured with the help of this Inconel X. Here in all these applications, higher temperatures will be there, and it will sustain in that higher temperature conditions due to presence of this titanium element. Okay, due to presence of this titanium added. And after this Inconel X, the next is the Permalloys. Permalloys, these are the alloys of the nickel and iron. 78% nickel will be there, and iron will be there. Approximately 22% iron will be there. Then it will be having very good magnetic property. Then hysteresis losses will be very low, and low electrical resistivity. Okay, low electrical resistivity, in other words you can say that it is very, it will show, uh, it it will show means it is very good conductor of the heat and electricity, means low resistance to the electricity it will provide. In that sense, means it will be better conductor of electricity. Then these permalloys are used for manufacturing of, or these are used in the manufacturing of the some loading coils which are used in the different electrical communication circuits. Okay, different coils, loading coils are manufactured with these alloys, and that can be used in the different electrical circuits. Okay, that are permalloys. And then after this, Alnico is there. Alnico nickel alloy is there. It is having 8 to 12% aluminum, 14 to 28% nickel, then 5 to 35% cobalt, and remaining amount of the iron will be there. It will show some magnetic characteristics or better magnetic properties. That's why these are used in the used as permanent magnets in different equipments like your microphones, and different types of the galvanometers, radio speakers, motors, generators. the magnets are required in these all equipments. That magnets are manufactured with the help of this Alnico materials. Okay, so these are some nickel alloys. Okay, just if you remember any 3 to 4 nickel alloys, it will be sufficient. They are not going. And if they have asked you the specific from these nickel alloys, they will ask you first 3 alloys. Okay, first 3 alloys only. Other alloys are for your reference purpose. Just go through it and their applications. So the in this way we have discussed this part, the different nickel alloys. Okay, up to in this 30 to 40 minutes lecture we have covered the lead and tin alloys, then different nickel alloys. Then after this we will discuss the next material, it is the babbitts. Okay, this is very important question or a very important alloy. These babbitts, compulsory question will be there on this babbitts. Okay, compulsory question will be there on this babbitts. Either they will ask you the microstructure of this babbitt material, or they will ask you the direct question that you have to explain these babbitts or white metal alloys. Okay, whenever explanation is asked, you have to start with their composition, then you have to mention some properties, then their application, and you have to draw the microstructure also. Okay, and if they have asked you only microstructure, then draw the microstructure and mention the phases in it. Mention, just you have to mention the phases. Okay, these babbitts are also known as white metal alloys, or these are also known as bearing materials, or it is also known as the anti-friction material. Okay, babbitts or white metal alloys, bearing materials, or anti-friction materials also. Now these babbitts, in simple way you can remember that these babbitts are used for manufacturing of the bearings. Okay, that bearings can be used for different applications or in different instrument bearings are there. Then different kinds of the bearings can be manufactured. These are white metal alloys used for manufacturing of the bearings. Okay, this is the general application. That's why these are also known as the bearing materials. Okay, now general composition, first point will be the general composition. These babbitts are either lead based alloys or these are tin based alloys. Okay, either lead will be their base metal or tin will be their base metal with antimony. Okay, with antimony, that is the SB. Lead is the, this is the lead, PB, tin. It will be either lead based or tin based, and compulsory antimony will be there, and some other alloying elements like copper, cadmium, arsenic will be added. Okay, will be there in the small amount. Okay, significant percentage of this antimony is present. That's why these are also termed as the trimetal. Okay, compulsory tin, lead, and antimony will be there. That's why these are also termed as the trimetal bearings. Okay, trimetal. This tin, lead, and antimony compulsory will be there in the significant amount. That's why these babbitts are also known as the trimetals. Okay, these alloys can be termed as trimetals also. Now lead based alloys will be having composition like this. Base metal will be lead, or parent element will be lead, then 1 to 10% tin, 10 to 15% antimony, 1.5 to 3.5% copper, and cadmium will be present 1.25 to 1.75%, and arsenic will be in the range 0.1 to 1%. Okay, this is the general composition for lead based babbitts. Then for tin based babbitts, tin will be balance whichever here, if you have, I have written here balance means it will be the parent metal. This tin will be the parent metal. These are tin based babbitts. Tin will act as the parent element. 1 to 10% lead will be there, 5 to 12% antimony will be there, 3 to 5% copper, and arsenic will present in very small amount up to 0.1% only. So these are the, this is the composition of the babbitts. These babbitts will be either lead based alloys or tin based alloys with antimony and some other alloying elements like copper, cadmium, and arsenic will be added in small amount. Okay, this is the general composition for lead based Babbit, and this is the general composition for tin based Babbitts. Then after this composition, the next point will be properties you have to write. Now in the properties, you can directly write the properties which are required for in the bearing, desired properties in a good bearing. That properties you can write as the properties of the Babbitts or these white metal alloys. Now here you can say that these are hard and wear resistance, and they will provide you the hardness and wear resistance for the very longer period of their lives. Then they are having sufficient load bearing ability at the room temperatures or the lower temperature values, as well as at the elevated temperature values. Then they are having very good fatigue resistance, galling resistance, and seizing resistance also. Then these Babbitts will be have, or they will have high oil retaining capacity. Okay, high oil retaining capacity. Then they will provide you very good corrosion resistance. Then they are having very or they are not having very low melting point or very high melting point. They will possess medium melting point and very good thermal conductivity. Due to this thermal conductivity, whenever due to the friction, heat is generated, that heat can be dissipated very easily. Okay, due to that, and these properties also will be there in the bearing materials or in the general bearings. Good thermal conductivity will be there, and these are having very less cost, and these are readily available. That's why, or you can use it for manufacturing of the different bearings. These are the general characteristics or properties used for the bearing materials, and all these properties will be present in these Babbitts or white metal alloys. These are also termed as the tri-metal bearings also. And after these properties, now we will discuss related to the microstructure. Now, this first point is not there. Okay, I forgot to eliminate it. Okay, you can refer from this second point. The microstructure of Babbit consists of hard cuboids. Cuboids are nothing but the cube-shaped particles. Now these cube-shaped particles will be of tin and antimony. Okay, and surrounding network will be of copper and tin will be there. Now in some cases, microstructure may consist of the complex compounds of the copper and tin. These are the complex compounds are there. Okay, some complex compounds will be there. Due to that, some needle shaped particles may be there. Now here, why copper is added, that questions may be asked in the reasoning also, or in the some objective questions. These type of questions may be there in the competitive examinations like GATE. Why copper is added in the Babbit? Now why copper first, before going for this deep discussion, I will show you the microstructures. Okay, actual microstructures. This is the microstructure. Okay, these are the samples, actual sample, and this is the drawing. Okay, microstructure of the Babbitts. This is the actual sample which you are going to observe. If you see the Babbitt material under the microscope, these samples are also available in our lab. Whenever that lab facility is available, I will show you these microstructures also. Babbitt material or white metal alloy. Okay, it will show the cuboids, that is cube shaped particles. White colored cube shaped particles will be there, and these are the cuboids of tin and antimony. Okay, Sn and Sb cuboids, and remaining black color portion, whichever black colored or dark portion is there, that is the network of copper and tin. Just the mixture will be there of copper and tin. Okay, and there are some needle like structures are there, white, this needle shaped. Okay, this is the needle shaped layers, white needle shaped structures are there. These are nothing but the different complex compounds formed by copper and tin. Okay, here I have mentioned it. Microstructure consists of hard needles of, these are complex compounds formed by copper and tin. Complex compounds are there. It may be needle shaped or sometimes it may be star shaped. Okay, these are the needle shaped, some needle shaped structure is there. This is due to the complex compounds formed by the copper and tin. Okay, generally, and you can draw the structure like this in the examination. This is the practical image, and in examination you have to draw like this. This dark portion will be copper and tin matrix or network, and this white color cuboids, cube shaped particular structures will be there. This is the SN and SNSB, that is tin and antimony cuboids are there. Okay, and if some needle shaped structures you can draw like this. Okay, these needle shaped structures will be there. These are due to the copper and tin complex compounds. Okay, this will be the microstructure. Then why the copper is added? Okay, here I have mentioned this copper is added to reduce the gravity segregation of the cuboids. Now what happens at the whenever you are manufacturing these bearings, while doing the solidification process, during solidification what will happen, these SNSB cuboids solidifies. Initially it will get solidified, this SN and SB cuboids, they solidifies first. And what will happen, these are very light, they will come at the top surface of that bearing. Okay, they will get all these particles of SNSB or cuboids of this SN and SB, that is tin and antimony will get segregated on the top surface of that bearing. Due to that what will happen, that top surface will become very hard in nature. Top surface of that bearing, it will become very hard in nature. It will become very hard in nature, and bottom part of that bearing, it will become softer in nature. Okay, hardness is not uniform throughout because of the segregation which is occurring due to the segregation of the cuboids of this tin and antimony. Now to avoid this segregation we are adding the copper. Here copper is added, and copper will form some complex compounds which I have mentioned here, this CuSN, then Cu6SN5. Like this complex compounds will be formed due to formation of this segregation of these cuboids does not occur. Okay, segregation will be avoided. And the segregation can also be avoided by using the rapid cooling rates. If you use the rapid cooling rate, it will get very lesser time to get segregated at the one place. Okay, due to this rapid cooling rate, either you have to use the rapid cooling rate or you can add the copper to avoid the segregation of the tin and antimony particles. Okay, for this purpose only, to avoid gravity segregation, which will result in the high hardness on the top surface only, we are going to add the copper element here. So this is the microstructure of that Babbitt materials. Okay, after this, sorry for disturbance. Then after this discussion related to composition properties, microstructures, and we will see the applications. Before the applications, first we will see the difference between we, initially we have seen that either we can use the team based Babbitts or we can go for the lead based Babbitts. What is the difference between their characteristics? The team based Babbitts or team based bearings will be there. They will show you, or they will provide you more corrosion resistance or better corrosion resistance and wear resistance and better load carrying capacity, but they will have higher cost. Okay, as our properties are very good in this tin based Babbitts, better corrosion resistance, better wear resistance, better load carrying capacity, it will have more cost. And lead based Babbitts or lead based bearings which are manufactured with the help of these white metal alloys, they will be having lesser corrosion resistance, lesser wear resistance, and lesser load carrying capacity with lesser cost. These are lesser values compared to tin based Babbitts. but you can use it for practical purpose. Okay, this can be used for practical purpose, but as far as their comparison is done, these tin based babbitts will show you the better characteristics or properties required for that bearing material, but it will be having higher cost. Okay, more corrosion resistance, more wear resistance, more load carrying capacity will be there, but it will be costlier. Then lead based babbit, in comparison with this tin based babbit, they are having less wear resistance and corrosion resistance and less load carrying capacity, as well as their cost will be very low as compared to these tin based babbits. Then these are some applications of these babbits or white metal alloys. Then I have separated some applications according to their types. Lead based babbits, these are used lead based babbits, first two applications used for general purpose machine, in the general purpose machineries, in the machine shops, in line shafting, whichever bearings used that are lead based bearings. Then these can also used in the farm machinery, then cement machineries, different conveyors are there in elevator applications, or in the steel mill machineries, lead based babbits are there. Then in the lorry diesel engine crankshafts, we can, or connecting rods. Here for this application we are using the tin based babbits. Okay, tin based babbits, whichever bearings which are using in the lorry diesel engine crankshafts. Okay, then another application here I have again included this in the connecting rods and crankshaft, where high impact load is there. Sorry. In short, you can say that where tin based habits are used whenever high speed and very heavy load is there, at that time we are going for this tin based habits. And whenever we are desired with whenever we are need that bearing with the low speed and with low speed and low load carrying conditions, at that time we are using lead based habits. Okay, whenever high speed and heavy load is there, tin based babbits are used. Whenever low speed and low load is there, then lead based babbits are used. Okay, few examples of lead based babbits in some farm machinery, cement machinery, conveyors, different elevators or machine shop equipments are there, and that lead based babbits are used. And tin based babbits, these are used where impact loading conditions are found on the connecting rods, crankshafts, or different lorry diesel engines are there in that crankshaft material. Bearings are used. Okay, these bearings will be tin based bearings or tin based babbits are there. Okay, in short you have to remember like this: whenever high load and high speed is there, tin based babbits are used. And whenever in that equipment that bearing or that part is subjected to the low load with low speed, that babbits or that bearings are manufactured with the help of these lead based babbits. Okay, in this way, in this lecture we have completed lead and tin alloys, then after that nickel alloys along with their composition properties and applications, and this babbits we have completed. These babbits or white metal alloys, these are also termed as tri-metal bearings due to presence of that lead, tin, and antimony. These are also termed as tri-metal bearings. Anti-friction material or bearing material, these are all names for these babbits only. This is very important material, babbits, as far as your examination is also concerned. Compulsory one question will be there. Okay, whenever this question will be asked, you have to explain in this way. First you have to mention the composition. Babbits are either lead based or tin based alloys with antimony and some other alloying elements like copper, cadmium, and arsenic. Okay, then composition for lead based, tin based babbits, here I have mentioned. Then for lead based babbit, then tin based babbit, then general properties. And properties, in short, you have to write the properties which are present in the bearing material or in the bearing itself. All that properties you can write here. Then the microstructure, you have to draw the microstructure, you have to explain the microstructure. Then why that copper is added, either you have to add the copper or you have to go for the very faster or rapid cooling rates to avoid the segregation of this SN and SB. SN/SB cuboids segregation. Whenever segregation occurs, what will happen? That material will become very hard at the top, and at the bottom it will become very soft. Okay. To avoid this, we have to add copper. Either you have to add copper or you can go for the rapid cooling rates. Okay. Due to addition of copper, what will happen? It will form the some intermediate compounds or complex compounds of copper and tin. Due to that, gravity segregation or segregation of SNSB cuboids or tin antimony cuboids does not take place. Okay, so that bearing will become hard in the uniform way on the top surface. Okay. Then in comparison of tin-based and lead-based babbitts, tin-based babbitts are having better wear resistance, corrosion resistance, and load carrying capacity with higher costs, and they will provide that properties with little bit inferiority. Okay. Then these are common applications: tin-based babbitts, high speed and heavy loads, and lead-based babbitts whenever low speed and low load applications are there. Generally, we are going for lead-based babbitts. Okay. In this way, in this lecture, we have completed uh, nickel alloys, lead tin alloys, and Babbitts. Okay. Thank you for attending this lecture.